it's now recording, and I would really like to introduce Chad. He is a really experienced software engineer and has a lot of experience with GitHub in particular. So he's offered to share his knowledge and his tips and tricks to do all of this GitHubbing. So take it away, Chad.
Thanks, Erica. Yeah, I'm Shad. I do. It is true. I do like Git for the most part. I'm also sensitive to the fact that it's a very difficult to use tool, so I'll try my best to help you guys learn how to use it. So I had a couple of prerequisites that are here on the that I'm currently projecting or sharing with you guys on the screen. There's to install Jupyter, install Git, and install GitHub. If you, create your GitHub account. If you haven't done these things, that's okay. You can just follow along. I'll try and go slow. But if you do have all these things ready to go, then yeah, feel free to try to do these things along with me. I'll take my time, and seeing as the class is kind of small, I can probably just wait for everyone to keep up. So yeah, that's prerequisites. So we'll be talking about 4 main tools: Git, GitHub, Review NB, and NBDime. Just a quick poll. Which one of these have you guys not used before? You can just post it in the chat.
Okay, we say out loud.
You can also say out loud.
Sorry, it's NBD time or Review NB. Yeah, I think that's for most of us.
Okay, I think you will like it. It's both of these tools are made. When I did the dry run yesterday, Erica and Aaron were most interested in those topics. So, all right, here we go. I'm getting a echo. Thanks. So hopefully by the end of our lecture today, you'll be able to answer at least to some degree the questions that are here. What is Git? What is GitHub? What is version control? What's a repository? What's a commit, fork, branch, diff, conflicts, pull requests? But I think the thing I'm actually trying to convey today will be the more practical aspects of using Git. So how do I push changes for others to see? How do I merge the changes that others have made? How do I let people know that I have a change that I want them to merge? And how do I look at the state of the repository? And a question that comes up very often is, what's the difference between branches and forks, and which one should I use? I'll try my best to answer this. I found it very hard to answer this question, mainly because it's kind of up to you. And I'll try my best to describe what the differences are, and we can sort of, maybe you'll be able to make a decision for yourself. So what is GitHub? So basically, GitHub is a platform for hosting your Git repositories. So GitHub will basically store all of your source code for you in a Git repository, and it provides a website basically that you can visit, and you can use it to view the state of your repository. You can also use it to go back in time to look at the state of the repository at other points, at previous commits, and you can also browse the files in the repository. But most importantly, what GitHub does, the primary function that it exists for, is to enable collaboration through pull requests. So if you want to have somebody review your code, you send them a pull request. And then the person who is in charge of the repo, or someone else who is an owner in the repo, they can review your code, and if they think it looks fine, they can merge it, or they can say, please make some changes, and then you make some changes, and then you merge it. That's the primary thing that it provides. Without GitHub, we don't have the ability to do code reviews. Also, GitHub does something kind of nice for Jupyter notebooks, because it's able to render them in the browser. And I think this is the primary reason why notebooks, why Git has become popular for hosting notebooks, mainly because you can store your notebook, and if you want anybody to see it, you can just send them the link, and then they can open the notebook, and they'll be able to see markdown text, source code, tables, and graphs. Yep, some graphs here. Any questions so far? All right. And feel free to just post questions at any point in time. I won't be interrupted. So to get started, to follow along, if you're planning to run the commands with me, start up your Jupyter. You can use regular Jupyter as well. I happen to have a preference for Jupyter Lab, but you should be able to do everything just fine in a regular Jupyter notebook. And also open up a separate terminal so that you can follow along with. So I'm going to be using a terminal to run the Git commands. So make sure you also have a terminal ready so that we can run commands together. Were you guys all able to see my terminal here? Just make sure that everybody's...
Yes.
Okay, cool. Thanks. Okay, so the way I want to try and teach how we use GitHub is through a bunch of examples. And we're going to be doing a story essentially for the whole lecture. In the story, Niwako is going to... She has a team, and I will be joining the team, but initially it's just her. And she wants to do an analysis of a COVID-19 data set. Okay, so we're going to pretend to be Niwako. Well, that is to say, I'm going to pretend to be Niwako. You guys can continue to be yourselves, and you'll follow along, and we'll do what she does. Okay. So in this example, we're going to create a repo that will be the team repo. Niwako will be creating her team repo on GitHub, and it will be her origin. She will clone it to her local computer, and then she'll make a change. So that's the example we're going to start out with. So I'll explain what all those terms are. I know I just dropped a bunch of them. If you have questions if I explain them and they don't make sense, please just let me know. I'll try my best to clarify. So let's begin with the demo. So the first thing to do is to create a new repo. If you have the slides open, then you'll be able to click on the links. If you don't have the slides open, go to shad.io and click on the first link in there, and you'll end up on the slides, and you can just hit spacebar to move forwards in the slides. So hold down the command button if you're on Mac, and I think it's Control on Windows, and then click the link so that it opens in a new tab. You can keep the slides open as well. So once you've opened up this new tab, this is where we'll create our repo. So if you don't have any ownership over any other organizations, then the owner here will just be your username. But Niwako is an owner of this repository called GitHub Jupyter, and she will be creating her repository here. So this, again, is Niwako's team repo for the COVID-19 project. So I'm going to call this COVID, and this is team repo for COVID project tutorial. And I'm going to make it public and initialize with a README. I generally like to initialize my repos with a README. You don't have to. The nice thing about a README is that it gives you something to clone. Otherwise, the repo is empty and no data gets transferred, so there's no proof that it actually worked. So far so good. Just go ahead and click the Create Repository button, and it will create the repo for you. So now Niwako has created her COVID repo in the team organization, and she's now ready to clone it and start the initial notebook that people are going to be collaborating on. So we click on this button here, code, and click on the copy button. I've been doing my stuff with SSH. I've learned recently, though, that HTTPS works just fine. Whichever one you're more comfortable with. If you don't know the difference, just the default's probably fine. So copy. And then we're going to head over to our terminal. And I've already created a folder called GitHub tutorial. This is where I'm going to do all my work. Feel free to do that too. I'll just show you how to do it. So the command to make it is mkdir space GitHub tutorial. I'm not going to run it because I've already done it, but you can type this, run it, and then cd into this directory. So you would type this command, and then you would type cd GitHub tutorial and press enter. Sound good? Everyone with me so far?
Yes.
Awesome. So the next step is to clone the team repo locally. So we'll just say git clone. So this is the command that we use for cloning a repo. So cloning a repo just means make a full copy of the repo that exists on GitHub on the local machine. And we paste the link that I thought, let's see, there we go. Okay, you paste the link that you copied from GitHub, hopefully successfully. And we need to, from here, you can actually press enter and it will make it'll make a folder called COVID and clone it for you. But because I need to demonstrate a certain amount of collaboration and I have to pretend to be a couple of people, I'm going to be giving the repos locally different names to represent who is doing what. So this is Niwako's COVID repo. But because it's not just Niwako's COVID repo, it's actually the team repo, I'm going to give it the full GitHub Jupyter COVID name. So this will clone the repository locally with this name. So we can press enter now. And it's cloned this repository into here. And now if you do ls, you'll see that we have a GitHub Jupyter COVID directory. And we can cd into this directory. Oh yeah, thanks Niwako. I've been using a color scheme to represent that when the background color here is yellow, it's going to be Niwako running the commands. And I have, and you can see the tab up here is Niwako. And then I have a separate tab for Shad, and he's got a dark background. So we cd into the GitHub Jupyter COVID directory. And if we now do an ls, we'll see the README file that we created. So far, so good? Is everyone able to see the README file?
Can you increase the font size of the terminal window just a little bit?
How's that?
Yeah, that's better. Thank you.
Cool. So the GitHub link is up. So on the GitHub Jupyter COVID page, there's a button called Code. And if you click on it, you'll see the link here. Is that what you meant, Aaron?
Yes.
Okay. All right. Yeah, that's okay. So if you've been following along, you wouldn't have been able to create anything under the GitHub Jupyter organization. So you will have made it under your own user account. That's okay for this part of the tutorial. If I interpreted your question correctly, Aaron. Okay, cool. All right. So let me just get a reminder of what I'm doing. So so here's what we've done. We've created the new repo on GitHub, and we've cloned the repo locally into a directory called GitHub Jupyter COVID. And the next step is to make a notebook file. So Niwako is going to work on this notebook now, where she's basically going to create the first draft of the document. So head over to your Jupyter lab or your Jupyter notebook and go into the directory that we just created and cloned from GitHub. So for me, that's GitHub tutorial and GitHub Jupyter COVID. And we're going to create a new notebook. Excuse me. And now we're just going to do some data analysis, right? So let's do it. Let's import pandas because everybody needs pandas. And what we're doing here is the US COVID cases. So now we need some data. Before we can do anything else, we probably need some data. I've made a link here, so you can make a plot using data from here. Again, hold Command when you click the Here button, the Here link, so it opens up in a new tab. And here are some CSV files. Let's choose the last one, 07/26/2020. This is John Hopkins GitHub repository. They update this. I think basically all of the dashboards that you'll find on COVID around like in news articles and stuff. This is basically the source, I think. So here's the CSV file. And what we're going to do is maybe we're just going to plot confirmed against the province/_state column. So I click raw here to get the raw CSV and then grab the link. I might be going too fast. Let me go backwards just a little bit. So once you're on the CSV file here in GitHub, the raw button here will take you to the raw version of the file. This basically allows you it provides you a link that you can use directly inside of a Jupyter notebook. So click raw and grab this link in the browser, copy it, head back over to Jupyter, and then I'm going to call it confirmed data frame is equal to pd.read CSV, paste this thing, and cdf.head so that we can see some data. There we go. How are people doing? The link to the raw file, Rebecca? Okay, so sorry about that. I know I have I'm sorry I went so fast. Let me try again. So on the slides in step 3, I have a link. Thanks, honey. That helps. That's actually better. Maybe I should do that. Yeah, so once you click on that link, it will take you to the GitHub page here. And then scroll down to the bottom so that you can get the most latest file, 07/26/2020.csv. And then click that file. And then click the raw button. And then from here, grab the link in the browser. And that's what you should use in your read CSV command. Thanks, Rebecca. Okay. All right. So I recognize that if you don't have two screens open at the same time, it's really hard to both watch me and do things with me at the same time. So I will try to go slower. Sorry about that. Okay, so now that we're able to see our data, let's plot it. Yeah. So we'll say cdf.plot bar, and the x will be this province state column here, and y is going to be confirmed. So the number of confirmed cases, and we'll just say fig size is equal to, I like 24 by 8 usually is great for my monitor. It's a big monitor. It happens to work well in this case too. So there's our plot, but I kind of want it sorted descending. So let's just say CDF equals CDF dot sort values by the number of confirmed cases, and we want it descending. So we'll just set ascending to false. So if we run this, yes, I can. Good idea. How are people doing? Rebecca, did you manage to get the plot? Nice. I missed the end of importing the CSV file. So did you get this piece of code here?
I did not, Miss Jen. Thank you.
Here you go.
Thank you.
Oh, you're welcome. I accidentally pressed escape and lost my chat. One sec. Okay, it's back. All right, there we go. Okay, sweet. So let's interpret this data like real data scientists. I'm going to pretend to be one today. So California has the highest bar. California is doing bad. That's the outcome of this analysis. Let's put that in a little thing here. California has the most number of COVID cases. All right. So we can save our notebook, and let's rename it. It's currently named Untitled. Let's name it covid.ipynb. Is everyone with me? Nice. Jen, how you doing?
I forgot to import pandas, so I'm behind, but it's okay. I'll listen to the recording later.
It's okay. I think we're doing okay on time. Don't worry. I think you just got one more statement to go. Let me see what we're doing next. Okay, so that's this. So now that we've made some changes to our notebook, we're going to commit the changes to Git and then push them to GitHub. So let's do that. So we'll just head over to the terminal again. So once again, I'm pretending to be Niwako. And we're going to say git status. So the git status command allows us to see the current state of our folder with respect to the existing commits. So what it's telling us is that we are on this thing called the master branch, and my branch is up to date with origin master. So let's break that down really quickly. So let's go back to the slide where I had an example. The master branch is usually just the default branch that's given to you when you create a new repository on GitHub. And origin here, it refers to the remote repository. So in this case, it's referring to the repository on GitHub. And specifically, in Niwako's case, it's referring to her team repository. So the team repo on GitHub owned by Niwako is called origin master. Then we have this next, sorry, any questions with that? Okay. So the next section here describes the set of files that are not currently part of the version control system. So it's saying that this file called covid.ipynb is not currently tracked. It's not in the repository yet. There's also this folder called ipynb checkpoints. So Jupyter makes these things. They are temporary folders as long as Jupyter is running. If you quit Jupyter, that file will disappear. So it's entirely temporary. And an interesting thing is we probably don't want to commit it. Excuse me. We probably don't want to commit it to GitHub. So we should ignore it. So the way we do that is we add ipynb underscore checkpoints to a .gitignore file. So the .gitignore file is it's basically a configuration file that lets you name files and name patterns of files, and it will basically ignore it. So I don't want to go too much into it. I can send you guys links on the interwebs that has documentation on how to use it. But I do want to ignore this file for the purposes of our tutorial. So there's an easy way to do that. We'll just say echo and copy this, put it in quotes, and remove the trailing slash and close quote, and then greater than sign .git ignore. I'm going to send you the command in the chat as well. So let's run that. And now do git status again. So as we can see, the untracked files have changed. Now, instead of ipynb checkpoints being a thing that's not tracked, it's instead this new file called .gitignore. And the most important crucial thing is that this is no longer being tracked. So hold on a sec. Let me just paste this in the chat for you guys to catch up with me. It occurs to me that might not work on Windows. If you're a Windows user, I'm actually not sure how to help. Hopefully, I'll find you some resources for Windows later. But basically, the idea is you just want to create a file called .gitignore with the contents .ipynb underscore checkpoints. Erica might know. Erica, does this echo command work on Windows?
I think echo works, but I'm not sure about typing to the file.
Okay. I think it works.
I think the safest way to go is create a new file in the notepad or something, and then add just that line, the gitignore, not the gitignore, sorry, the .ipy blah blah blah.
And then save it as .gitignore. Yes, that will work too. Okay. Thanks, Erica. And thanks, Niwako, for the suggestion. That was great. All right. So now that we're in this state, let's commit our files to Git. So the first thing to do is to stage the files. This is a Gitism, if you want to call it that. The idea is there's a place called the staging area where you prepare your commit before you actually make the commit. So whatever goes into staging is what will end up in the actual commit. And whatever is not in staging will not go into the commit. So for example, if you weren't able to add the .ipynb checkpoints to a .gitignore file, we could just not commit it at all by not adding it to staging. So let's stage these two files. So we're going to say git add .gitignore. So this has added the .gitignore to the staging area. And if you do git status again, you'll see that these are the changes to be committed. And specifically, it says .gitignore is staged for commit. And Git helpfully tells you how to unstage it in case that was not what you wanted. Let's also add covid.ipynb. So git add covid.ipynb. And I will send these commands through the chat as well. This one. and this one. And if we look at git status again, we'll now see that our 2 files are staged and ready to be committed. So now we can commit it. So to commit the files, we just say git commit, and we press enter. So now we're presented with an editor where we can type in the commit message. But this editor is not the most user-friendly editor there is. It's called Vim, and I'm not trying to teach you Vim, but I will teach you the bare essentials necessary to write your commit and quit this program. So Vim is actually very much, it operates kind of like a Jupyter notebook in the sense that there's 2 modes. There is the editing mode where you're typing in a cell, and then there's the command mode where you're just navigating around, like going up and down, adding cells, deleting cells, that sort of thing. So Vim is like that. It has 2 modes. Right now we're in the command mode, and we want to type a message. So we type the letter I, and that goes into insert mode. Now we can type our message. And the message we want to say is added confirmed US confirmed COVID cases. Yeah, okay, that's fine. Period. So now we're still in edit mode. To exit edit mode, you press escape, actually, which is just like Jupyter. If you press escape while you're editing a cell, it will go into command mode. And then you press shift semicolon to get a colon so that you can type a command, and then X. So just colon X, and then press enter. And that has created the commit. So let's take a look at it. If we do git status, if we do git status, we have a new set of messages here. We're still on the branch master, but now we have a new message here. It says that our branch is ahead of origin by 1 commit. So let's break that down. Let's take a look at this picture again. Inside of origin, there's a set of commits there, and inside of Niwako's local repository, we just committed something, but that commit doesn't exist yet in origin. We haven't sent it there. And so as a result, our branch is ahead of origin's branch by 1 commit. And we could keep committing, and we would be more and more branches ahead of our origin. But if we want to push these changes to origin, then we do git push. I'm sorry, I may have been going too fast. Is everybody with me? Okay, sounds good. There will be another opportunity to resume from a clean slate, Aaron and Jen. So don't worry about it. Shortly. Okay. All right. So the next step is to push our changes to origin, and the command for that is git push. All right, that's it. Now, let's do git status again to see what it says. It says nothing to commit. The working tree is clean. This means that, and we're on branch master, and we're up to date with origin. So that means that our branch is in sync with origin's branch, and there are no further changes in the directory. We are totally synced up. So yay, that's good state to be in. Let's see. There's a cool command that lets us take a look at the set of commits currently in the repository. I'm just going to say this really quickly because I'm going to be using this a lot as we start to deal with more and more commits. It's called git log. So if you run git log, what you'll see is the set of commits in order that they were committed. And there's a certain set of options that I really like to use. I'm going to share it with you, and I'll paste it in the chat shortly. It's git log graph all one line. I have an even better one, and I'm happy to share it with you guys later, but it's very long, and so you have to make an alias out of it. I'll put it in some, it's in the last slide, so if you're willing to use it later, I'll share it with you. But the idea here is that it lets us quickly see the relationship between all the commits in the repository. And this is going to help with our visualization as we're trying to sort of understand what the repository looks like. I use this a ton. Like, this is how I understand what's going on. So yeah. Yeah, there's the command. Git log graph all one line. All right. So the last step is to take a look at the notebook on GitHub. We pushed it there. So let's head on over to the repository that we created, and let's refresh the page. So now we have .gitignore, and we have our COVID IPyNB, and Niwako added US confirmed COVID cases. Thanks, Niwako. Good job. So if you click on the COVID IPyNB file, you will see the notebook we made. So here it is. This is the head. So we see our table, we see our graph, and we see our message. California has the most number of COVID cases. Honey and Rebecca, did it all work out for you? Nice. Cool. Okay. So let's talk a little bit about these tools that we're using. What is Git? Git is a distributed version control system, and a version control system is software that keeps track of the history of files in a repository. So this raises, I think, some more questions. What's a repository? And a good way to describe it is that it's basically the place where all your files in your project are stored, and every version of that file that you've committed is also stored in this repository. And this will include other branches. So if you make a commit, and then you make another commit, and then you go back in time to a different commit and make a different commit, that's a branch. Your repository holds all of that information. One mental model that Aaron gave me yesterday that I think is useful is to think of each commit as a kind of folder that is linked to each of folders that are linked to each other. So the first time you commit, it's kind of like creating a folder, and you've put all your files into that folder. And then when you commit again, another commit, it's like duplicating that previous folder and changing the files in there. So that's version 2 of the folder. The important distinction between folders and commits is that commits actually store the differences between the folders. And so the links matter. But otherwise, I think that that's a good analogy. So then, what's a branch? So I thought this was Erica, when she looked at a later slide that we're going to come to, she thought this was a really good way to describe it. So let's say that this green, everything that you see in green is the mainline branch. Anything that you see in blue is Shad's branch. Anything in purple is Niwako's branch. If you're colorblind, then green is, I'll click it with my mouse. It's mainline here, commit A1, this, commit A2, this one, commit A3, and this one. The blue ones are at the top here, these two things here, and the purple are these two down here. So a branch basically happens whenever, let's see. Let's just go through the example. That works well. So initially, the repository starts out in the state. It's a story, basically, chapter 1, with some very ordinary prose, and then chapter 2. And the rest of the book hasn't been written yet. So Niwako and I get together, and I say, I'm going to be tidying up chapter 1. And Niwako says, okay, I'll write the ending. So we get together. Sorry, we go off. We do our and we start doing our own thing. Niwako completes her task very quickly and merges her branch, which is the feature branch for the ending of the story, into commit A2. So what she did was she made a branch off of A1 to tell the end of the story. She committed it to C1, then she merged her changes back to mainline with the ending of the story. Meanwhile, I was very slow with my changes. I needed to clean up chapter 1's prose. So I ended up committing slightly later than Niwako did. So I updated the prose, some wonderful prose, and I go to merge, and because the changes have been made in separate parts of the file, this merge can actually occur automatically. Niwako's commit C1, which is now in mainline at commit A2, is merged with my commit B1, and then I commit it to mainline at commit A3. And it contains both of our changes. So branches are basically a way for us to split off of mainline and work independently of the changes that are happening in mainline. And then when we're ready, we can merge those changes back into mainline. Questions? Cool. Thanks, Rebecca. So how does it work? So repositories in Git can be hosted either on GitHub or on a local machine or anywhere else, really. For the purposes of the kinds of things that people use GitHub for, typically you'll have a team repo, which is often called the upstream repo, and you'll have a personal repo, which is called origin. And origin, in order to get origin, which will be in your personal account, you typically will fork the upstream repo. So let's just quickly talk about what that means. So when you fork, what it's actually doing is making a full copy of upstream's repo in your account. And then when you clone your origin, you're again doing the same thing. You're making a full copy of the repo that's in origin onto your local machine. Okay. So what are pull requests? So if you make a change in origin, and you want that change to be reviewed and then pulled into upstream, that's what you will make a pull request. The idea is you are requesting an owner in upstream to pull your changes, hence pull request. That's why it's called that. So when you send somebody a pull request, they will essentially get a diff of the changes, right? And the diff will basically show what's different between Aaron, that sounds like an internet problem. That is very weird. I'll chat with you offline, see what happened. Sound good? So when you send the pull request, the reviewer is going to basically see the diff between what's currently in the repository and the changes that are coming in. So you'll often see it look like this. It'll be red for the things that have changed or that are being removed, and green for the things that are being added. So that's the gist of it. We'll see more of it later when we actually do the demo. So let's revisit our example. So far in the story, Niwako has created her COVID repo in the team repo, that is, and it is her origin. But from my perspective, because that's the team repo, it's going to be my upstream. So I've renamed it. Niwako still, of course, has her local repository, and I've tried to match the colors down here with my terminal. I thought that was kind of cute. Anyway, so what I'm going to do is fork the upstream repo into my repository, and you all can do the same with me. So let's go back to let's see here, let's go here. So here's the demo. And if you didn't make it through the last demo, this one here is relatively independent. We can try again. So what we want to do is fork this repo into our personal accounts. So if you click on, hold down the command button or the control button in Windows and click the link to open it up in a new tab. And we're going to go over here to the fork button. And this will make our own copy of GitHub Jupyter COVID in our account. Thanks, Erica. Yeah, that's a better idea. I should copy paste the links there. So once you click the fork button, I don't think actually you'll be presented with this unless you happen to have more than one destinations for a fork. It should just happen automatically, but if not, click your username, and then it will it'll be forking GitHub Jupyter COVID into your personal account, in my case, Shadanan COVID, right? And I can see that Niwako has made changes. So this is now my fork. How's everyone doing? Okay. How about Jen? How are you doing? Okay, great. Nice. Okay. Next step. Let's go back to our slides. So we just did step 1. And okay. So the next step now is to clone our personal repo locally. So let's do that. So we're going to say git clone, and this time we're going to be passing it our forked repos URL, and then we're going to give it a different name. So come over here, click on the code button, and then copy this. And then let's head over to our terminal. And now I'm no longer Niwako, I'm going to be Shad. So here's Shad's new color. And Shad's going to say git clone, paste the URL, and then let's put our names on it. So type you don't have to do this, but it's a good idea. I'm going to call mine Shadanan-COVID. And you can call yours your username -COVID. And then press enter. So now we can cd into Shadanan COVID and do an ls, and we'll see Niwako's initial commit. So let's continue. Let's see. So there's a problem with this document so far. The problem is that even though California may have the most number of cases, California is also a very populous state. So we really ought to normalize it, maybe find number of cases per capita instead of total number of cases, because it might be a different picture. So let's do that. So this was Niwako's notebook. Let's close it. And now we're going to open Shad's notebook. There we go. So here it is. And you should now be seeing the changes that Niwako made in her repository. This is where we're at so far. So let's run her notebook. Yep. Okay. And what we're going to do is we're going to update the notebook to show COVID cases per capita. And we need some state information, state population data in order to be able to do that. So we'll just basically click on either Kaggle if you have a Kaggle account, but Erica and Aaron were able to track down the original source of this data. And this one doesn't require an account, so you can click this too. It'll bring you to the worldpopulationreview.com page. If you scroll down, right here in very light gray, in the US states ranked by population 2020, there is a download CSV button, along with ads, obnoxious ones, in fact. So we click on the CSV file here, and it asks us to save it. I'm going to call it state-populations. Save. Okay. Head back to our Jupyter notebook. There it is, state populations. Great. So let's help Niwako out. Let's give her the number of cases per capita. So cases per capita. So we're going to say, first thing to do is, I think, load the data. Let's see. PDF. So this is population data frame is equal to pd.read_csv state populations.csv pdf.head. And we have a state column that we should be able to join on, and a pop column that I assume is the population, I guess, as of 2020, because we also have pop 2010 and pop 2018. Here is the code I just typed so that you can easily add it to your notebook. And now we just need to merge the two data frames on state. So on this column state here, and on province state from the previous one. So let's do that. pd.merge CDF, that's the confirmed data frame, confirmed cases data frame, with the population data frame. And the left, so the left column is called province state. Let's grab that. And the right is called state. Let's take a look at it. So let's see if we joined, it would be at the end. So it looks like at least the first 5 joined all right. So that's good news. It's not always the case, but I did this beforehand. That's why I knew it was going to work. Percent confirmed is the column we're going to add. That will be the per capita data. And basically it's the confirmed cases divided by the, I believe it's called pop. And we're going to use percentage, so times 100. Okay. Let's plot it. And I'm just going to, yeah, let's just type it. we'll just say df.plotbar. And now we're plotting the province underscore state against the percent confirmed. Yes. I'll do it shortly because I plan to modify it. I'm making mistakes on purpose. Okay. Fixed size is equal to 24 by 8. All right, looks good. Let's just sort this now again so that we have it descending. So just say df equals df dot sort values by the percent confirmed ascending equals false. And now we have a beautiful chart. And sure enough, while California may have had the total number of cases, the most number of cases that is, they're sort of middle of the pack when you do it per capita. So here's the code for merging. And here is the code for plotting. Oh, yeah, we can, if you want, I can chat with you a little bit afterwards, Aaron. Okay. All right, so let's see where we're at. So we just updated the COVID notebook with the per capita data. And now we need to push the changes to our origin and make a pull request against upstream so that Niwako can review it and merge the changes. So let's head back to our terminal. And we're just going to do git status. Always good to do git status. So we've modified the COVID file, and the state population CSV file is a new file that needs to be added. So before we did an add command on every file. There's actually a shorthand to just add everything in the directory that's changed. You can just say git add space dot, and this will add every file that's currently unstaged into the staging area. Then you can do git status, and we'll see that COVID IPyNB has been modified, and there's a state population CSV. That's a new file that we're adding. So we're ready to commit. So we'll just say git commit. And if you want to avoid opening up a Vim terminal, a Vim window, you can get around it by saying git commit -m and then typing your message directly in here instead. And then it won't open up a Vim. You can just have your commit message just right here in the terminal. This is often a little bit more convenient. And if Vim can be finicky, if you want to avoid it, this is an easy way to do it. So git commit -m, and we'll say COVID cases per capita. Let's actually say added COVID cases per capita. So that's our commit message. Here it is. And now we can push it up to origin. So git push. So let's use that command we used before, the git log command. So git log --graph --all --one line. And let's see if we can interpret the output here. So what this says is that there are 3 commits currently in the repository. The first one, the latest one that is where our current head is pointed at. So it's called we're on the this is saying that we're on the master branch, and the current pointer is on master. This is also saying that origin is at the same commit as our master. So if you did git status here, you would see that, yes, I'm on branch master, and the branch is up to date with origin. Give me a sec to see if I can silence these notifications. I'm sorry. Okay. All right. Great. So let's take a look at our changes. So if we go back to Shadan in COVID and refresh the page, we'll see now that I have made changes 2 minutes ago. And what I've committed is the state populations, and I've updated the COVID IPyNB. Now I'm ready to ask Niwako to review the changes so that she can merge it back into the team repo. So all you have to do is click this pull request button, and it's ready to be pull requested. So let's scroll down and see what the changes are going to be. So what we'll notice is that covid.ipynb is here. If you click load diff, what you'll see is a bunch of JSON gobbledygook that is essentially human unreadable. Human people won't be able to review this. So that's going to be Niwako's problem, I guess, to deal with. Create pull request. Now you're given the option to type in a comment for Niwako. And you just click create pull request. So this pull request is ready. Oh, that's fun. Okay, so you're not going to see what on your machine. You're probably not seeing this, I imagine. Are you? Are people seeing this? Okay, good. So let's head back to our slides. We've done all the things now. We've used GitHub to create a pull request, and we took a look at the state of our repo. So things were coming along. Now we're ready to start reviewing. So as we saw, if we go to so in this pull request, if Niwako were to come here and click on files changed, she wouldn't be able to review this. She would only see that we've dropped a state population CSV file and a diff that is, as I said, human unreadable. But there's a solution to this. It's called review NB, and I'm going to teach it to you now. So it requires that you install it into the repository where you want to use it. So let me copy the link and paste it in chat. You won't need to do this. Maybe you don't need to click this. You can watch from now on. I'll just demo. So the next step is to essentially install this app into our repository. So you click on the link, and it will take you to the app page where you can set up a free trial. And we're just going to do a free one because you can. And we're going to install it into the repository where we want to be able to use it. In this case, Niwako wants to be able to review notebooks. So she's going to install it into GitHub Jupyter and install it for free. And complete the order and continue and type a password. And I think we're all set to go. Okay. Save. Okay. So now if we click on, oh, this looks weird. Hopefully things are not broken. Let me see what happened here. Okay, everything's fine. So if you finish the installation in your own repo, you'll see this, and you'll be able to select repository. In this case, we're selecting GitHub Jupyter COVID. And if you click pull requests, you'll see the pull request that Shad sent to Niwako, the one I sent to Niwako, that is. So if you click on this pull request, we now have the ability to go to changes and expand the COVID IPyNV file. And we can actually see a human readable diff. And the way it works is by diffing at the cell level instead of at the line level, which is what Git normally does by default. And because notebooks are JSON documents and the lines are not the unit of diffing, it typically does the wrong thing. But this tool knows how to deal with Jupyter notebooks correctly. And what we can do is we can scroll through here, and Niwako can see that this part of the notebook here hasn't changed. Everything here remains the same, but from here on, it has changed. It has identified that the address of this plot changed, but that's nothing to worry about. The important stuff is below, where we added the cases per capita, this is the reading in of the state populations data, and the final plot at the end here. So Niwako might look through this and she might make some comments. She can say, good job. Start a review. And then click the finish review button and submit. And that will submit a review comment to Shad in this case. So we can now go back to GitHub and see what this review NB app has done. So if we click on C on GitHub, it takes us to here, where this is the pull request that I originally opened. And Niwako has given me, well, Shadannon has given himself a good job comment. So at this point, I could resolve the conversation and merge, but we'll save that for a moment. Any questions? Okay, thanks, Jen. So let's talk a little bit about some of the commands that you're going to need to do in order to properly manage your commits in a Git repository. So as I mentioned, there are branches and there are multiple repositories. There's the one that's local, and there's typically the one on GitHub, often referred to as origin. So let's take a look at this particular scenario where in our local environment, we have 2 commits on mainline and a branch, which are these blue commits up here. On origin, there are 3 commits on mainline in green here, and 1 commit on the branch. So in Git terms, what this is, master is ahead, origin master is ahead of local by 1 commit. Origin's master. And local's branch is ahead of origin by 1 commit. So how do we synchronize it? That's the question at this point. So there's several useful tools. So the first one is git fetch. So git fetch is nice because it's always safe to run. All it does is it downloads all the commits that exist at origin or from other repositories to your local repository. So in this case, if you did git fetch on origin, it would download the 1 commit that local is missing, which is the last commit, C2A. So far, so good? Okay. Then we have the git pull command. This is kind of similar, actually, to the git fetch, except that it also updates the current branch to be equal to the branch in origin. So if we were in this state, and now you did git pull on master, it would move the master branch pointer to the same point, to the same commit that origin has it pointing to. So that's that operation. There is a caveat to that, which I'll get to. And lastly, we have a git push. So what git push does is, so in the same way that git pull pulls down a commit from the remote repository, git push takes your commits and pushes it up to the remote repository. But it will only synchronize those commits that are part of the current branch. So in this case, before, I messed up the slide, sorry. Before, origin didn't have this commit. And then when we did a git push, we pushed this commit D2F over to origin, and origin's branch pointer moved from 4AB to D2F. So that's all very academic. We're going to see shortly how to use these things. But before we do that, let's talk a little bit about conflicts. So far we've looked at branching and doing pull requests and stuff like that. What happens if people have made changes in the same place in the file? So it will typically result in a conflict, and conflicts need to be manually resolved. So as we saw when we originally did branches, sometimes it's possible to merge successfully. Sometimes, though, the merging algorithm has to give up and essentially get some human help. So let's take a look at an example that would cause that. So it's the same story as before, but in this case, at commit A1, there is the story, some very ordinary prose. And then Niwako and I discussed things, and she misunderstood. She thought she was writing chapter 1 as well, updating chapter 1 as well. So she updated some beautiful prose in chapter 1 and added the end to chapter 2. Meanwhile, I only updated chapter 1's prose, and what we updated it to is a little different. Not very different, but just a little bit. So Niwako commits her change back to mainline, and now in commit A2 in mainline, we have some beautiful prose as well as they lived happily ever after for the ending. When I try to push my commit, though, to A3, I'm going to get a merge conflict. And Git will tell me that the text for the prose could not be merged successfully. It will, however, have merged the ending. That part it wouldn't have had a problem with, usually. So in here, I'll have to come in and manually say, I guess I want some wonderful prose, not some beautiful prose. And then I will resolve the conflict, and then I'll be able to push my changes to A3. So let's see how we would do this with Jupyter notebooks, because it doesn't work very well, but there are tools out there to help us. So we need to, well, before we get into that, I think the best way to deal with a conflict is to just not have them in the first place. And one strategy to avoid having conflicts is every person can have a separate notebook that is their own with their initials on it, for example. I know that Niwako and her team do this. It's a perfectly reasonable approach to avoiding conflicts. And it doesn't require lots of technical expertise in Git to do it that way. And in my personal preference, I actually would rather do it that way. But sometimes you're in a situation where you have no other choice and you do have to deal with a conflict on a Jupyter notebook. And these tools will help you. Oh yeah, the last thing to mention here, if you do have separate notebooks with initials, you're basically going to anoint someone as the source of truth notebook czar, essentially, and they're going to keep track of that notebook for you and merge changes from all of the different contributors. It's okay when you have a small number of people on the team, but it can become unwieldy if one person is just constantly having to deal with merging other people's work. So let's see. I guess let's revisit our example. So I did a pull request to upstream for Niwako to review, and she reviewed it, but we haven't merged it yet. Now, the story that we're going to do is that the story I'm going to tell you now, Niwako, while I was making the cases per capita, she was off. She also recognized the same problem, which is that if we only show the confirmed cases, it's a problem because it's not representative of the actual challenge that that state might be facing. Another way to do it, Niwako realized, is to show the positivity rate, which is the number of positive cases per tests. And Niwako went off and did that. So let's simulate a conflict by having Niwako make that change before we've merged my changes into the master branch. Okay, so that's the story. Is everybody clear on the story? Cool. All right. So let's close this one and let's go back to Niwako's repository. So that's this one here. And let's open up her COVID file. And it currently doesn't have my changes yet. And she often went and was doing positivity rate, okay? So the positivity rate is going to be the number of people tested divided, no, sorry, backwards. The number of confirmed cases divided by the number of people tested. Okay. So let's do that. We're going to say CDF of positivity rate is equal to CDF of confirmed divided by the number of people that were tested, and make it a percentage. And let's remember to sort our values this time. Sort values by the positivity rate. Sending is false. And last, we plot it. Plot bar. And now we're going to plot the state against the positivity rate. Big size is equal to 24 by 8. Let's double check the code first before I paste it. Okay, there we are. So similarly to when we did per capita, we also see that this causes California to move sort of to the middle of the pack. And it causes Arizona to actually jump way up here. So their positivity rate is quite high. So that's nice. Well, no, that's not nice. But we're finished this piece of the notebook. Nice. So now let's commit our changes. Or let's actually see where we are. So let's head back to, so Niwako is now finished her change on master. She modified COVID. She adds it to the repo, git commit. Message will be added positivity rate to COVID analysis. Git push. So her changes are now in the upstream branch in the team repository. Let's go take a look at our pull request. So our pull request is here. And now we see that this branch has conflicts that must be resolved. And the conflicting file is covid.ipynb. And as so just to recap the story, Niwako added positivity rate, and I added the per capita. And because we modified our files at the same time, and she committed first, I am no longer able to merge my changes with the team branch because we have a conflict. So the next step is to somehow resolve the conflicts. So let's do that. So the first thing to do is to merge Niwako's changes with my local copy so that I can fix the conflicts and then freshen up the pull request. That's essentially the plan. So to do that, I need to add Niwako's repository as a remote to my repository so that I can merge her changes into my main line. So this is the origin we want to add. So the command to do it is here. So we can just copy it. I'll paste it in the chat as well. So we're back to being Shad. And we're going to say git, sorry, I'll just paste it. Git remote add upstream. And then now we're adding the team repo. Hit enter. Now we're going to do a git fetch. So this will pull the changes from whichever repository we specify. So in this case, I want to fetch the changes that exist in upstream. So yeah, okay. Now I can run our git log command again. This will be very instructive, I think. So git log graph all one line. So what this is showing us is where the divergence in our commits occurred. So we have our initial commit, so far so good. Then Niwako added the US confirmed COVID cases, so far so good. And I have added the COVID cases per capita, and Niwako in upstream has added the positivity rate to the COVID analysis. So what I need to do is merge the changes in upstream with my master so that I can resolve those conflicts. So the command to do that is git merge upstream master, I think. Let's try. Okay, so that created a conflict, and we can now try to resolve the conflict. So here's the problem. If I go to my COVID file in Shidanen COVID and try to open it, it says this. You might see something different. Cancel. And it spins forever. So by attempting to merge the changes, Git has broken the notebook and I can't open it anymore. So that's unfortunate. But we can fix it. So if you end up in a situation and you need to get out of it, you need to abort, you can do that. And the help will be given to you with the status command. If you do git status, it will tell you that currently COVID IPyNB is the one that is conflicted, and we currently can't open it, so it's got a problem. But we can abort by saying git merge abort. So git merge abort. So if we can't view the changes, then how do we merge the changes, right? So the tool that we're going to use is called nbdime. And all you have to do is install it. The command is pip3 install. This is what they had on their website. If you've never installed it before, then you probably don't need the upgrade. But pip3 install nbdime. And then you have to do nbdime extensions enable. Then, so you do this once forever on your computer, that is. And then every time you work with a repo that has Jupyter notebooks in it, you'll want to run this command, nbdime config git enable. So let's run it. What this has done is it's configured this repository to be able to work with Jupyter notebooks. That's essentially it. Now we can try to merge again, and it will use the new tools. So git merge, and we're merging again from upstream master. So you'll notice that the messages are slightly different. We still have a conflict that we still have to resolve. That part's not new, but the part that is new is this piece. It's saying that an app called nbmerge app did the merge for us instead of Git's default merge tool. So now we can use the nbmerge GUI to help us resolve those conflicts. So we ran that merge command, and the merge tool we're going to use is this one, git merge tool nbdime. You don't need to just copy paste it. Here it is for everyone. And if you run this, it will open up the a three-way diff, which allows us to attempt the merge. So let me just, I'm going to quickly head back to a previous slide where I can easily explain to you a three-way diff. So when I was committing my change here, what I would see in my merge tool is on the left-hand side would be the original version, the one that's in the repo currently in mainline. I will see Niwako's change, and I will see my change. So the three-way diff shows me all three versions, and I get to pick which one I want. That's essentially what we're doing here. So here's nbdime, and it's presenting us with this three-way diff. Okay. So let's see what it's trying to tell us. Notebook metadata has changed. Okay. It's blue. I think you can usually ignore the blue stuff. It decides that that's not important differences. Then we have the differences in the charts. So this is going to be the address differences. And again, it's blue. As far as nbdime is concerned, it's not a difference that matters. But if we scroll down a little bit more, it highlights in red the areas that we should care about. And in this case, it doesn't know how to merge the cases per capita with the positivity rate. It's saying that there's a conflict here. Now, this thankfully is a very simple merge. All we're going to do is just combine everything. We're not in a situation where the cells themselves have a conflict, but if we had one of those, this tool will show it to us as well. So we can click the resolve conflict, and everything will just be fine. Now, if we wanted to make certain changes, like let's say this cell was not needed now that we have done this three-way merge, we could check this box and it would remove that cell for us. Or if there was conflicts in the output, maybe the data has changed, you could click the clear outputs button and it will remove the outputs. So the next time you run the notebook, you'll just get some fresh output anyway. But so far, so good. We've resolved the conflicts across these two files. And then we can just scroll back up to the top and click save. And it'll say merged notebook saved successfully. And then we can click close tool. And if we go back to the terminal, it's finished. And more importantly, if you do git status now, we'll see that covid.ipynb is no longer conflicted and it's ready to be committed. Now, there's a couple of extra files here. There's this covid.ipynb.orig. This is the version that we had before we attempted the merge. So if you wanted to, if for some reason, you wanted to keep it around, it's still there. Usually it's not necessary because Git will, every commit you make, it keeps it. So nothing will be lost if you just delete this. So we'll just remove the orig file. And this Git attributes, I was trying to read up on what this is. It looks like some state information for nbdime. As far as I can tell, it's not needed. So I've just been deleting it. Maybe one day I'll find out that I shouldn't be doing that. Don't worry about it, I guess, for now. It doesn't cause any problems as far as I can tell. So I'm going to remove it. So let's take a look now at the status. So COVID ipynb has been modified. Now, before we do anything else, we should verify that the notebook still works as we expect it to. It's always good to make sure that what you finally merge into the team notebook repository it's really good to make sure that it runs from top to bottom without any modifications. And the reason for that is that most people, when they open your notebook, they're going to want to run it from top to bottom. And it will help them a lot if they don't have to figure out why it didn't work for some reason. So let's do that. So we're going to try and open COVID again. As you recall, it wasn't opening before, but now it opens. And furthermore, it has been successfully merged correctly. So we have our cases per capita, and we have our positivity rate. So that's wonderful. Interestingly enough, the numbers that index the execution order for each of the cells is actually out of order now because those were pulled from separate notebooks. So all the more reason to restart the whole notebook and just run it again from the top. And the notebook works, so that's good news. I'm happy about that. We can save it. And let's go back to the terminal. And if we do get status again, we'll see that it's been modified slightly. The modifications in this case are basically going to be the addresses for the output images and the index numbers for the outputs and the inputs of the cells. So no big deal. Git add, and now git commit. And the message is merge cases per capita with, what is it? Positivity rate. So let's take a look at the graph again. So git log. All right, let's try and understand what we're looking at. We have our initial commit, and we have the US confirmed COVID cases. That was the one Niwako did. And our origin is currently pointing to this commit. So our personal repository on GitHub is pointing to the COVID cases per capita. Upstream is pointing to this commit. And our master is the only one pointing to this new commit that we've made, which is the merge commit, the commit that combines the two other commits. So we can push this now to origin. Let's do that. Let's just do git push. And let's look at the log again. Nice. So this was where our origin master used to be on this commit. It has now moved up to the same commit as our master. So we are now successfully synchronized with our personal account. Now, hopefully, we'll be able to check our pull request, and it should be good to merge now. So let's do that. There it is. Checking. +1. Looks like we can merge again. No more conflict. So that's good news. So let's reply to the good job, I guess. Thanks. Comment and resolve the conversation. And then merge the pull request. Merge the pull request. Confirm. Okay. Let's head back to our terminal and fetch from upstream. So git fetch from upstream. The reason why we're doing this is because when you make a change in upstream, like merging a commit or something like that, you change the state of upstream. And if you fetch, you'll basically pull down what those changes are. So git fetch from upstream. And let's take a look at what is different. Git log again. So this is, I think, quite psychedelic. We have our initial commits. We have the case where we were trying to merge. Then we created a merge for the cases per capita with positivity rate. And then Git, when we did the pull request, created yet another commit in upstream, which is a merge pull request commit. So that's great. So if we want to now be at the same state if we want our master branch to be at the same state as upstream's master branch, then we need to pull the changes from upstream. That will move our branch pointer up to upstream. So we'll just say git pull upstream master. Let's look at the log one more time. So now our master is here, pointing to upstream's master. And now we just need to synchronize our local repository with our fork. So git push to origin master. In this case, you could have just said git push. The default is origin master. Let's look at our log one last time. So there it is. Everybody, upstream and origin and local, everybody is here. So that's great. I may have been going a little bit fast there. How's any questions? Cool. No questions. Thanks, Rebecca. Cool. Yeah, you can. So the question is, could we pull directly instead of fetch, then pull? You can. The reason why I tend, could we pull directly? Did you, oh, you meant could we pull to merge? Yeah, that's an operation you can do. I didn't cover it, mainly because I don't use it. And I always do it this more sort of, I'm very direct with my commands. And like, I want to do this very specific thing. But pull can also merge for you. So if you did a git pull against upstream master, it would have attempted a merge on your behalf. And then when you complete the merge, it would then in addition do a pull. So it would skip a few steps, but this works too, whichever way you prefer. There's a lot of I'll be linking to a few cheat sheets that we can use to help with this stuff. There's a lot more to learn about Git that I have avoided covering because I feel it's a little bit too confusing to teach. It's really hard to teach, specifically rebase and more advanced kinds of merges, which can help keep our commits kind of clean. We have a bit of time, so I'll address it really fast. But if you take a look here, the log history here has a lot of branching going around, all because we had a merge conflict. And if you look at other repositories, some of them you'll see they behave this way, but a lot of other repositories have a much more clean sequence of commits. Sometimes, especially developers, they like keeping a very clean set of commits. And the reason for that is it's easier to move back in time to other commits when the sequence is not quite so complex. Like if it's just linear, then it's easier to jump back in time. The problem with that approach is that it can be slightly dangerous in that if you botch a merge, you won't see the previous commit anymore. It still exists. It's not gone, but you don't see it anymore. And for beginners, it can be scary to think that you may have lost a commit. So the world has decided, GitHub has decided, everyone has decided that the default merge plan is this three-way merge, as opposed to some other strategies that can often lead to a cleaner looking repository. I may have gone off on a tangent. Sorry about that. Let me see if there's anything else to talk about. I think I'm just about done. Yeah. So I have a Git cheat sheet here with some information of things that you can take a look at. There's the git config, which is I didn't get to talk about during this talk. I left it out. But basically, a lot of the commands that we ran configure that file, like the nvdime command. It created a file .gitconfig and added some stuff to it, which is how it configured itself. There's also a global one where you can configure nvdime if you wanted to to work for all your repos. It exists there. For the most part, you don't need to know about it, but it exists. I thought I'd point it out. The most useful tools for me are git status and the git log. And if you never run into any merge conflicts, this plus git pull is basically all you'll ever need. Git add, git commit, git push, git pull. If you do run into some merge commits, you have the video that we made, this one that's being recorded. You can watch that section again to understand how to do it. Over time, this actually does become easier, believe it or not. I've also linked to GitHub's cheat sheet, which I thought was nice. And I know that Aaron had another cheat sheet that looked good too, but I didn't have a chance to review it and forgot to link it in the slides. Let's see. So yeah, here's a summary of things that you've learned. Basically, Git and GitHub are, Git is a tool for interacting with Git repositories, and GitHub is a hosting platform for those repositories. So on GitHub, you'll typically have a Git repository that you can clone locally. You will have a set of commits that consists of files, versioned files, and you can go to any of those files at any point in time. And you can have branches. Then you have tools like git fetch, git pull, git push that enable you to synchronize your local repo with the remote repo, with the GitHub repo. And yeah, I think that's basically it. And there's some forking involved as well when you're working with teams, but the majority of what you need to know is, it's sort of contained in this picture. If you understand over time, this picture works well for understanding what's going on. It's basically like a prettier version of the git log command we looked at. So I'm ready to take some questions, but before I do, I wanted to show you guys one little tool that I think is kind of nice, and it does help with when you're collaborating. It's called Black, and it's this little button up here in your Jupyter notebook. And what it does is it auto formats the code for you. And the reason why this is nice, I use this at work, not Black specifically, but a tool like it. The reason why this is nice is that without it, developers have a tendency to nitpick each other's code. And I think not just developers, anyone who has any aesthetic sense for code at all cares about how their code looks. And what it leads to is a lot of review comments that are like, could you put a space here? Or, this line is too long. Could you break it up a little bit more? And those tend to just slow down development. So some people have decided that they don't want to deal with that anymore. They just have a tool that will always format things consistently, and it's a very opinionated formatter, so nobody is allowed to talk about their opinions about the code format anymore. So I'm going to run it and show you what changes. So there's some single quotes here. When we click it, so you'll see that it changed my single quotes to double quotes. It moved the line down one, added a space here. In general, made my code more tidy. As it is, I had very little code to tidy up, so it didn't have much work to do. But I find it to be a very helpful tool for when we collaborate. So that's my presentation. If you want to install Black, I provided the link here. So feel free to take a look at it. It takes a bit of effort to get installed. It's a little bit on the buggy side for Jupyter because it's designed for Python scripts, not specifically for Jupyter files. But the guy who makes this tool is very responsive to bug requests. So I think it's a cool tool. Any questions? Yeah. So there's two meanings to that revert. If all you want to do is see an older version, you can. And there's a couple ways that you can do a revert. One way is a dangerous way, and the other way is a safe way. I'll show you both. So let's take a look-see here. Yeah, so this one's going to be a little hard because we just did a merge commit. So I'm going to make an additional commit Let's see here. Let's go back to my Jupyter notebook. So I made it in there. Git status. So this is the formatting change I made. Git add, git commit, format notebook with black. So we formatted it and we pushed the change. So the first thing that you might want to do is before reverting, maybe you want to see an older version. So if you do the git log command, we can see our previous commits. And if we wanted to go back in time to this one, we could. So we could copy this and we can say git checkout this hash code. And it will tell us that now I'm in a state called detached. It means that I don't currently have a branch name associated with my current commit. Let's take a look at what that means. So head is pointing here, but there's no current branch here, right? Master is over here. So this is one way to see the notebook at an older version. If we go back here and refresh this page, we'll see that it's back to the way it was. Now let's say that we're only dealing with our own personal repository, okay? So in this case, we are not modifying, nobody else uses our repository, it's just ours, or maybe it's our personal branch, so nobody else is using it. We're gonna do the unsafe thing, and then I'll follow up with the safe thing. So the unsafe thing is to just delete that other commit, remove it from history. This is typically not recommended on any branch that you are sharing with someone else. So here's how you do that. Basically, you're going to delete the master branch here, reassign it to this commit, and then force push it to origin so that origin no longer knows about this commit. That's the operation we're going to do. So we do git branch -d. This is a command to delete a branch, and we're going to delete the master branch. Let's take a look at the log. So now the master tag is gone, okay? So now we can create a new tag, a new master tag, and we'll assign it to where we are right now. So that will be git branch master, git log. So there's the master. And now we can just go to it, git checkout master, git log. So now head is pointing at master. So we've moved the master pointer in our local repository from origin back to the commit that we're on here, okay? So now if we want, we can push to origin master and force it to forget about that old commit. Git push origin master -- force. So always be careful with this particular command. It is still possible to go back in time. Nothing is ever truly lost, but it gets harder and harder the further down this rabbit hole we go. Git log. It's gone. We've erased it from history. So that's how you do it the dangerous way. Now let's do it, I guess, the less dangerous way. So the less dangerous way is not quite as dramatic. The less dangerous way is actually just copy all the changes that were in the branch you want to revert to and make a whole new commit out of it that just undoes the change, right? I don't know that one off the top of my head. We'll have to Google that one. But let's do it together. Let's see. So first, let's make the change again and save it. Git status, git commit, and then we're going to say format with black, git push, git log. So there we are. We're back to the state we were in. Now we want to undo it, and we're going to undo it the safe way. So this is the situation where other people are using the branch with us. So what we want to do is essentially grab the versions of the files that they were here and make a new commit out of them. So use our trusty Google to do a search for git undo merge, undo commit. What would we search for? Git commit. I'm not sure what to search for. But what we can do is actually just copy the files out of that version into the current version. So git get file from previous commit. Yeah, so that's basically what we want. So we'll go to our terminal, git checkout from this hash code, the file we want to revert, which in this case is COVID IPyNB. Git log, let's take a look. Nothing's changed, that's good. Git status. So we've modified COVID IPyNB. It's now the version that was in this particular branch, this particular commit. And if we go to Jupyter and you've installed, oh, it doesn't work. Well, that's unfortunate. Oh, that works too? Good to know. Is that the one that creates that just replaces the files with the versions that were in that commit? Code like a girl. How to undo this.
According to that site, that's what you do.
Okay, we can try that shortly. Let's just do a quick diff here. So it's not the easiest to read, but it is doing what we think it's doing. So it's putting these things back to the way it was. So if we were to open this file up again, yeah. So this reverted this version of the file. Let's try Erica's one as well. So so that was one way to do it. So let's just git restore staged version of COVID and git checkout. And now let's try that. Git revert to, oh, it's already moved past. So we want this one. Git revert to this hash. Okay. There's probably a way to also revert all the files from, hold on a sec, git. I have a hypothesis that you can just type git checkout dot. Yeah, that also works. So if you do git checkout and then the hash code and then dot, it will just pull every file from that commit into a new commit that you can make now. So if we open up the COVID file here again, it has in fact reverted our the formatting change. And now you can make a new commit. Git commit revert the black formatting. So those are the two ways to do it. One way allows you to just erase the commit from history. The other way basically reverts it by applying a new diff that removes the change. Other questions? My pleasure. I was happy I was able to do it. I just don't make mistakes, so just avoid mistakes altogether. Obviously, I'm joking. I make lots of mistakes. Other questions? Okay. Well, I guess that's time. Thanks for coming to the tutorial, everybody.
Thank you, Chad. This was really interesting. This was an awesome tutorial. I think everyone learned something new today.